students. Let us come back to the second topic, next topic, important topic again of polynomial chapter. We come down. In the previous lecture we discussed about remainder theorem. Today we discuss about the factor theorem. We all know what is a factor. Simple excuse, if I talk about, if I take two simple examples, say 15 divided by 3. So we know 15 divided by 3, the remainder is what? 0. So we say that 3 is a factor of 15, or we say 5 is a factor of 15. We can say 3 into 5 are the factors of 15. Another factors of 15 are 15 and itself we know what is a factor. When do we call it a factor? When the remainder comes out to be what? 0. So that is factor theorem. Same way now here we will be discussing factor theorem for polynomials. If p of x is a polynomial of degree n greater than or equals to 1, greater than or equals to 1, you can see x is power of 4, x cube, x square, x and 1, the degree is 4. So it is greater than 1 and is a natural number for a instance. And a is any real number. A is any real number. Then x minus a is a factor. Can you see it was plus a? X minus a is a factor of this polynomial if the remainder is 0. We had discussed the remainder theorem in the previous lecture. Then the remainder p of a is equals to 0 if it is a factor. And another form, if p of a is equals to 0, that is the remainder is equals to 0, then x minus a is a factor of x. If x minus a is a factor, remainder is 0. If remainder is 0, x minus a is a factor. These are two factor theorems. Now there are various methods of factorization that we will be studying in this chapter in class 9 as well as in class 10. Right now we come down to exercise 2.4, that is the application of factor theorem. We can see that p of x is x plus 4 plus x cube, x is power of 4 plus x cube plus x square plus x plus 1. We need to check if x plus 1 is a factor. Well, let us come back to the factor. When x plus 1 is a factor, then the remainder is what? 0. So if x plus 1 minus 1 is a real number. Yes or no? To check if x plus 1 is a factor, we know that p of minus 1, x plus 1 minus 1 must be equals to 0. So therefore p of minus 1, x plus 1 was a factor, so plus 1 goes on the other side, minus 1, x minus 1 minus 1 raised power of 4 plus minus 1 cube plus minus 1 square plus minus 1 plus 1. Yes or no? We did it previously. Minus 1 raised power of 4, negative number raised to even power, result is positive, plus minus 1 raised power of 3, the result is negative. So minus 1 into plus minus 1, negative number raised to even power, result is positive, plus into minus, minus plus 1. Right? Plus 1 minus 1 cancel, plus 1 minus 1 cancel. What is the remainder? Plus 1. When x was minus 1, we substituted, the remainder is coming out to what? Plus 1. Because p of minus 1 is not equals to 0. That is remainder. Remainder is not equals to 0. So therefore x plus 1 is not a factor of the polynomial. If this remainder would have been 0, we would have said that it is a factor. But because p of minus 1 is not coming out to be 0, we say it is not a factor. Correct? First question, it was second part for your help. Now it is the fourth part. Some of us feel difficult in this room. So let us substitute. What does the minus 1 plus 1, minus 2 plus 2 plus root 2 plus root 2, 2 root 2. Minus 2 plus 2 cancel, the remainder is what? 2 root 2. P of minus 1 is 2 root 2 because P of minus 1 is not equals to 0. That is, remainder is not equals to 0. So therefore, x plus 1 is not a factor of the given polynomial. That is your factor theorem. Remainder theorem and factor theorem both are mutually related to each other. This is what we discussed in remainder theorem. Here it is in the same in the form of factor theorem. I hope first question is clear. Second question, use factor theorem to determine whether gx is a factor. You can see polynomial is given to you gx and it says check whether gx is a factor. Okay, so again we will substitute it and we will check whether it is equal to 0 or not. If the remainder is 0, we say it is a factor. If the remainder is not equal to 0, we say it is not a factor. Clearly stating nothing new. Clear? There is nothing new in that. Same thing that we did. The remainder has to come out to be what? 0. The only difference, two polynomials are given to us. Yes or no? If I talk about second question, three parts are there. Second question, second part, let us discuss. What is the polynomial P of x? X cube. P of x is equals to x cube plus plus 3x square plus 3x plus 1, and another polynomial g of x is given to us as x plus 2, right? Substitute. We need to check whether gx is a factor of px. So when can gx be a factor? If the remainder is 0. If P of x, now what will be x from here? 0 from here, minus 2. P of minus 2 is equals to 0. Then gx is a factor of px. Agreed? Yes? X plus 2, what is the 0 from here? Minus 2. So minus 2 when we substitute over here, if the remainder is 0, then we say it is a factor. Let us substitute. So therefore P of minus 2 is equals to minus 2 cube plus 3 into minus 2 square plus 3 into minus 2 plus 1. Minus 2 cube minus 8 plus 3 into minus 2 square 4 plus into minus 3 to the 6 plus 1. So minus 8, 3 4s are 12, minus 6 plus 1, right? Minus 8 and minus 6, minus 14, 12 plus 1, 13. So 14 minus 13, minus 1. P of minus 2 is equals to minus 1. What is the remainder? Minus 1. Because P of minus 2 is not equals to 0. So therefore, G of x is not a factor of P of x. Clear, students? If it is a factor, the remainder has to be 0. As if we talk about the third part, let us talk about the same question, third part. You can see x cube minus 4x square plus x plus 6. Substitute, right? Third part, you will see that as well. No harm. Third part, the polynomial P of x is given to us as x cube minus 4x square plus x plus 6, and gx is given as x minus 3. Right? So again substitute. So therefore P of x in place of x, what is the 0 from here? Plus 3. Plus 3 and minus 3 is what? 0. So P of plus 3. In the polynomial P of x, we substitute 3. 3 cube plus 3 plus 6. So 27 plus 3 plus 6, 36 minus 36. Remainder is what? 0. P of, can you see the remainder is coming out to be 0? Because P of 3 is equal to 0. That is what? Remainder is equal to 0. So therefore, G of X is a factor of P of X. Clear? So you can see two of them we discussed factor theorem. What do we mean by factor? What does it mean? What does the remainder mean? What does the factor mean? I hope it is clear. This is the factor theorem that we have to discuss. In the previous lecture we discussed about the remainder theorem. Both the theorems are important. And your next class 10 is also based on remainder theorem and factor theorem. Students, you can see there is a relation. If x minus a is a factor, remainder is 0. If remainder is 0, x minus a is a factor. They are vice versa. Now we shall study about third question. Check, he says, if x minus 1 is a factor, he is telling us that it is a factor. If it is a factor, if x minus is a factor, the remainder has to be 0. So simply, we were checking whether the remainder is 0 or not. And now, in the third question, he is telling us that it is a factor. So we have to substitute the value and the remainder has to be 0. I am talking about third question now. Let us talk about any of the parts. You will be able to understand the vice versa of that. Here we were discussing whether it is a factor. Now he is telling us that it is a factor. Right? Third question, if I talk about, there are 4 parts. Third question, I think we should discuss the second part first of all. You will find it a bit difficult. P of x is equals to 2x square plus kx plus root 2. Right? And x minus 1 is a factor. And x minus 1 is a factor of px. He is telling us that it is a factor. Yes or no? It is a factor. If it is a factor, the remainder has to be what? 0. So check over here. Because x minus 1 is a factor of p of x. Therefore, remainder p of plus 1. Can you see that? Minus 1 was a factor, so the 0 is plus 1. P of plus 1 is equals to what? 0. Substitute. P of 1 is equals to 2 into 1 square plus k into 1 plus root 2. And how much is P of 1? Remainder 0. 0 is equals to 2. 1 square 1. 1 2 is 2. K 1 is k plus root 2. In these questions we were checking. Here he is telling that it is a factor. Can you see that? That is the difference. So we need to find k. Transpose both of them. Plus 2 comes over here, minus 2 plus root 2 comes over here. So minus 2 minus root 2 is equals to k. What is common? Minus, so what is left? 2 plus root 2 is equals to, simple. Here we were checking whether the remainder is 0 or not. Here the remainder is 0 because it is a factor according to your question. Clearly stating that it is a factor. Another one, if we talk about, say, fourth one. Second question, fourth one. P of x is equals to kx square plus 3x plus k. Sorry, it is not plus 3x, it is minus 3x. Here also x minus 1 is a factor. And x minus 1 is a factor of px. Agreed? Because x minus 1 is a factor of px. Therefore, the remainder p of 1 must be equal into 1 square minus 3 into 1 plus a. So p of 1 is what? 0. That is the remainder is what? 0. 1 square 1 into k minus 3 ones are 3 plus k. Minus 3 comes over here, plus 3 is equals to k plus k, 2k. So therefore 3 by 2 is equals to k. 2 is in multiplication, 2 is in division. This is your remainder theorem, or we say the factor theorem. That is exercise 2.4. Question number first, second and third. Students, please understand it. It is given to you, the factor theorem is also given to you in your textbook. I have given the statement from the textbook, that is on page number 40. Page number 40, this theorem is given to you on page number 40. You can go through it and read it. There are examples given to you. You can understand by the examples as well. Clear? So please check that. Now, after coming this factor, he says find the factorize. Factorize the polynomial. He tells us to factor the polynomials. Now there are two important questions and very important topic, as it will be again there in class 10. You have done factorization in class 8. We will be doing it again in class 9, and 2 chapters of class 10 are based on that. One is polynomials, there it is factorization of quadratic polynomial, and then we have quadratic equation. There also we have to do the same. So today we will be discussing about factor theorem, and in the next video you will find we will be discussing about the factorization as well. Clear? Please check it and understand it. Thank you.